Good morning, everybody. Nice to see you.
Good morning.
So we're basically done with this semester. We've just got today and tomorrow, and congratulations, by the way, for getting through, mostly getting through what is definitely a challenging and unique semester. So we've just got one thing left to do. We've got the final assessment that'll be tomorrow. And in order to facilitate that, try to make it as stress-free as possible, what I want to do today is kind of take a broad overview of what we did like over the semester and also give you specific problems that you can work on overnight if you want. And I'll take the final assessment directly from those problems that I give to you today. Like it won't be all of them because we only have an hour, but I'll pick from those problems and make the assessment out of that. Sound good? So let's try to get to it. And I'll post this on the Google Classroom as well. So basically, we worked on chapters 1, 2, 3, 4, 5, and 7. We didn't do everything from every everything from every chapter. So it's worth it to go through and look on what we did. So for chapter 1, uh, we did section 1.1 to 1.4, and you can basically split this up into two parts. The first part is section uh, 1.1 to 1.3, and that had to do with like solving a linear equation. Sorry, just rearranging something here. So that had to do with like how to solve a linear equation, like for example, 2x plus 3 equals 0. We've been using this so much throughout the course. Good morning. It's nice to see you. So we're just discussing what's going to be on that final assessment tomorrow. I'm going to like literally write down, or I've already typed them out, but I'm just sort of like showing as I go along the the questions from which I'll select tomorrow's assessment. Okay, and so like with these linear equations, we've solved them so much, like to do other things, you might be pretty used to it by now. You're isolating x. So like here, you're subtracting 3 from both sides and then dividing by 2. Do a couple more examples or practice problems from section 1.1 to 1.3. Now, section 1.4 was a little different. That was what we call these absolute value equations. So one thing I'll ask you to know for tomorrow's assessment is like what is an absolute value? Absolute value of x is like distance from x to the origin, or you could say um, like if x is negative, the absolute value of x is positive. If x is positive, the absolute value keeps it the same. Examples from 1.4. I should keep, so I'll try to keep track in the book too. Sort of two modes of learning. You can see the review and see where we were in that book. If it rings a bell. So here are, some examples you can look at. Examples I could draw from for the assessment. Yeah, so something like absolute value of x plus 2 equals 3. How do you do this? Remember, the idea is whatever is inside the absolute value sign, that can be equal to 3, or it can be equal to -3. So you write down both equations and solve each one if possible. So the first equation is like x plus 2 equals 3. You solve that to get x equals 1. And the second equation is x plus 2 equals -3. Solve that to get -5. So there's two values of x that that solve this equation. So you can think about it as like it tells you which two values of x make x plus 2 have distance 3 to the origin, or to 0. But that's the trick to remember for these absolute value problems. Like whatever's in the middle, that could either be like the right-hand side, or it could either be the negative of the right-hand side. And some more that you can practice on. This one, you'd have to add 10 to both sides first. You can see it worked out in example 2 if you like. And for this one, you would have to divide both sides by -4 before taking the step of putting what's inside the absolute value equal to either -13/4 or 13/4. But 3 questions to practice on. I'll perhaps pick one of them for the final assessment. So that was really all we did in chapter 1. It was the solving equations and the absolute value equations. So to go on to chapter 2, what did we look at? I think we did 2.1 to 2.4. And chapter 2 is all about these inequalities. So first, how do you... Well, first we have to make sure we remember what all these symbols mean. Less than, bigger than, less than or equal to, or bigger than or equal to. And remember, we did this stuff with like graphing the inequality on the number line. So like you fill in the dot if it's less than or equal. So for instance, like here's some problems you can look at. Like, can you graph the inequality r bigger than or equal to absolute value of -5? This is kind of silly because you don't need the absolute values. The absolute value of 5 is equal to 5. So this is just another way of saying r bigger than or equal to -5. The book just wrote it that way to kind of test our understanding of absolute values. For this one, solve it and then graph. You're just adding 6 to both sides. For the next one, when you have an inequality, remember you can multiply or divide by a positive number and the inequality stays the same. So this, you could multiply both sides by 5/4, and that'll just solve the inequality. But on the other hand, where's page 71? Let's come down a little bit. On the other hand, if you look at like this section 2.3, the thing that we really had to learn, my computer's being a little slow. It doesn't want to let me scroll up very fast. The thing we had to take care is, like, if you look at number 27 on page 71, so here I am on page 71. So error analysis, describe and correct the error in solving the inequality. Um, what is the error in the inequality there? -6 is bigger than 2/3 x. Oh yeah. Yeah, so this is kind of what I'm talking about. So the thing we had to learn was that if you multiply an inequality on both sides by a negative sign, by a negative number, that inequality switches. But if you multiply both sides by a positive number, the inequality doesn't switch. So like you could multiply both sides by 5/4 in this example and solve the inequality. But look at what the person's doing here. They're multiplying both sides by a positive number 3/2 and also switching the inequality. And that's not correct. So the thing, like the takeaway message from this section 2.3 was that like if you solve an inequality by multiplying both sides by a negative sign, then you have to reverse that inequality. So for instance, like if you look at number 17 on page 71, I would solve this by multiplying both sides by -4, cancel out the -1/4. But then I have to switch the inequality. So I would end up with, so multiplying both sides by -4, -4 times -8 is 32. Instead of less than, it would be bigger than m. Is the solution there. So I'll just leave that there for you. The thing to be careful of. Multiplying both sides by a negative sign switches the inequality. So that's the thing that we spent some time on. That's good to remember. But that's it for chapter 2. Any questions before I move on to chapter 3? So chapter 3, that was about lines. So given an equation for a line, can we graph it? And we did probably 3.1 to 3.6. I know that 3.6, the transformations of graphs, like all that stretching and shrinking and so on, was tough for us. So actually what I'll say is maybe I'll make a question about 3.6 as a bonus, but that's not going to be required for the assessment. So you're not going to be required to answer questions on section 3.6. So hopefully that's kind of like a early into the semester gift for you. But I'm mostly interested in 3.3, 3.4, and 3.5. You know, thinking about what's going to be useful for you later, like you're going to use quite often. And that was function notation. And even more important is 3.4 and 3.5. So recognize an equation and graph it in standard form. Recognize an equation and graph it in slope-intercept form. See if we can get down to 3.4. Adobe Acrobat is just killing my PC right now. The CPU is like almost at 100%. It's ridiculous. But neither here nor there. So standard form of the equation. So here's an example of something that you might be asked. So graph the equation 3x plus 4y equals 12 using the x and y intercept. So when you see something like this, that's standard form. It's number times x plus number times y equals a number. We've learned a number of ways to graph things. I'm not going to be picky about like the particular method that you pick to do something. You know, graph it any way you like, that's fine. But when you have something in standard form, there is like an easy way to do it, and that's using these x and y intercepts. Remember, the x-intercept is when you set y equal to 0, and the y-intercept is when you set x equal to 0. And when you set x equal to 0 here, you get that you get 4y equals 12, so you get that the y-intercept is 3. When you set y equal to 0, you get that the x-intercept is 4. So you plot those 2 points and connect the dots. And you can see page 131 for more detail on that. In fact, here is that example worked out, setting variable y equals 0 to get 4, 0 as the x-intercept, setting variable x equals 0 to get 0, 3 as the y-intercept. Then you connect those dots. You can see a couple more practice problems there. So that was standard form. And then the next section, we're talking about slope-intercept form. And slope-intercept form is when you had the y equals mx plus b. And that number m is the slope, and that number b is the y-intercept, because that's what you get when you plug in x equals 0. And for an example, you might say, like, here's y equals 1/2 x plus 3. Please graph the equation. And I think the best way to do that, remember, you only need 2 points. 2 points make up a line. So you can pick x equals 0 to automatically get the y-intercept. So 0, 3 is a point on that line. And then you just plug in x equals 1 to get the other point and connect the dots. I'll write it out here briefly. So if you plug in x equals 0, you'll get y equals 3, substituting in 0 there. If you plug in x equals 1, 1/2 plus 1/2 times 1 plus 3 is 3.5. So you plot those 2 points and connect the dots. And that's the best way to graph an equation like that. Just plugging in 0 and 1, looking at the values you get, then plotting those 2 coordinates. So that's chapter 3. So any questions or comments on that? Would you like me to do one of those problems in more detail? Or should we move on to chapter 4? So we'll move on for now, but you can always direct message me a question or just interrupt and I'll answer your question. Chapter 4. So if chapter 3 was taking an equation and graphing it, chapter 4 is like taking 2 points and finding the equation that goes with it. So it's like doing chapter 3 in reverse. So what we call writing linear equations. And of course, we're skipping 4.4 to 4.7. We didn't cover that. So of course, you won't be tested on it. It's 4.1, 4.2, and 4.3. You can break this up into 2 parts. And the first part is, given 2 points, can you write the slope-intercept and point-slope form, and the other part was this parallel and perpendicular stuff. Let's look at the examples. You could say something like, write an equation of the line that passes through the given points, -3, 5, and 0, -1. And my advice or my hint for that is to use the slope formula to find the slope of the line. And you've already got the y-intercept here, because when x equals 0, that gives you the y-intercept. And I'll actually do this on the document camera here in a second. Let me write this down. -3, 5, 0, 1. So you might benefit from seeing this written out. There we go. So the question is, can you write the equation for the line that goes to the 2 points? And I'm going to write y equals mx plus b. I'm going to use slope-intercept form. And the reason why I want to do that is because I already know that b is equal to 1. And the reason that I know that is that b is the y-intercept. It's what you get. It's what you get when you plug in x equals 0. And here I've got x equals 0, y equals 1. So I know that the y-intercept has to be equal to 1. So all I need left is to find the slope, and that's the difference in the y values over the difference in the x values. y2 minus y1 over x2 minus x1. So I'm going to take y2 minus y1, so 1 minus 5, over x2 minus x1, so 0 minus 3. 1 minus 5 is -4. 0 minus 3 is 3. So the slope is -4/3, and therefore y is equal to minus 4/3 x plus 1. I mean, if I also wanted to graph this, well, I'm given 2 points. So I'm given x equals 0, y equals 1. So I'm given that this point is on the graph. I'm also given -3, 5. So x equals -3, and then y is equal to 1, 2, 3, 4, 5. So -3, 5 is like around here. So if I just connect those dots and extend through, then that gives me a graph of the line. If I picked the method where I said I'm going to take x equals 0 and x equals 1, so x equals 0 gives me y equals 1. That was one of the original points. Or just plugging in x equals 0 gives you y equals 1. X equals 1 gives you y equals -4/3 plus 1. 1 is 3/3, so this is like -1/3. So you get this point, x equals 1, y equals -1/3. So x equals 1, and if you sort of keep on going down, then that's the point, y equals -1/3. So you could also have picked those 2 points and connected them. But you can see it doesn't really matter which points you pick. Any 2 points will give you the same line. And you don't have to be a great artist. Certainly I'm not a great artist, but because I've labeled my points for the most part, it kind of makes sense. Okay, get this screen share back up and operational. I'm sharing a portion of my screen. Every time I switch to the document camera, Zoom just resets and like doesn't keep the same window. Zoom needs to have some teachers on staff to like suggest features and things. Okay, so that was this example. And you've seen me work it out, but of course, like it'll be your challenge to work it out tomorrow during the assessment, like if it's one of the questions that I pick. But you can see like why my advice makes sense. Use the slope formula to find the slope of the two lines, and then you've got the y-intercept there. For another example with more practice, do the same thing with 0, -2, and 4, 10. So that's section 4.1. There's also 4.2 with, instead of slope intercept, we do point slope. And a slope intercept is good for when you have a slope and the y-intercept like this, but point slope is good when you just have 2 points in general. And how do you solve this? Well, you use this point slope formula that like y minus y1 equals m times x minus x1. So my advice for solving these is find the slope with the slope formula, then use slope intercept form. So y minus y1 equals m times x minus x1. And you can choose any point to be your x1, y1. Like I usually choose the first point, like 7, 2, to be 7 is x1, 2 is y1. And then you've got everything you need to plug in. The y and the x stay variables. You found the slope with the slope formula, and you plug in like 2 here and 7 there. The last thing we did in chapter 4 was this business of parallel and perpendicular lines. And the two things you need to remember there, if a line is parallel, it's got the same slope. If the line is perpendicular, it's got what we call the negative reciprocal slope. So what are examples that you could be asked? I could say, write an equation for the line passing through the point -3, 1 and perpendicular to y equals 1/2 x plus 3. So the tools you need to solve this, you need to identify that 1/2 is the slope of the given line and that you want something perpendicular to it. So you want the negative reciprocal of 1/2, and that's going to be -2. So reciprocal meaning you take the denominator, and negative, just put the negative sign in front of it. So you're using that same point and slope -2. So once you've got the point and the slope, you just use point slope form. So those questions are kind of fun once you get used to it, because you can read off the slope and the negative reciprocal is going to be -2. You've got the point given to you, and then you'll use this slope intercept form plug in -2 here, and then plug in -3 for x1, plug in 1 for y1, and that'll give you the answer. I could also have said, like, write an equation for the line passing through -3, 1, and parallel. And in that case, it's the same deal, but you want the slope to be 1/2. You want it to be the same as the given slope. But those are the kinds of questions I'll ask for a 4.3. So any questions or comments on chapter 4, or anything you'd like me to go in more detail? Okay, we're getting close to the end. We're getting into things that may be more familiar because we've done them more recently. So chapter 5. Once we learned about lines and how to graph them, we moved on to system of equations. So 2 linear equations at once. We looked at 5.1, 5.2, and 5.3. So you will not be tested on the rest of the sections. And this was really, you could solve systems by graphing, by substitution, or elimination. So to try to make your study a little bit easier for tomorrow, I'll make a deal with you. So I won't cover 5.1 and 5.2. I'll only cover 5.3. So you won't be responsible for solving systems with substitution or by graphing. You'll only need to solve systems with elimination. So what are some examples of that? Well, certainly you can go down to section 5.3 and there's lots of worked out examples and some examples in the homework, but I've written down 2 of them here. So maybe 11 and 12 on page 251. So here's page 251, and there's 11 and 12. So solving by elimination. So that's when you're multiplying one equation by a number and then adding it to the other one. So for number 11, what I might do is I might multiply the first equation by -2. So I get opposite signs, -2x plus 2x. Then I add those 2 equations together and solve for y. Once I figure out y, I can plug back into the first equation and get x. For question 12, I might think about multiplying the second equation by -4. Then adding it to the first equation. Or sorry, multiply the second equation by -2 and adding it to the first equation. Multiply the second equation by -2, you'll get -8x plus 6y equals -10. And the x's will have opposite coefficients. They'll cancel when you add them together. You'll solve for y and then plug back in to find x. So that's really all I'll test from chapter 5. Chapter 6 is for next semester. We didn't cover that this semester. Chapter 7. So now we're getting into stuff that's quite a bit more recent. And the things that I'm really interested in, things that I'm really interested in are 7.2 and 7.5. That's really the core of the material. So that's all I'm going to focus on. And those 2 things are really like FOIL, like how do you multiply 2 binomials? So first outside last. I mean, I guess the book says first outer, inner, last. Doesn't really matter. So for example, I give you x plus 2 times 2x plus 4. Like, what's that equal to? You FOIL it out, and or t plus 3 times negative t plus 2, like use FOIL to find the product. 7.5 is like FOIL in reverse. It's like Leoff. um, so this is when we're factoring. So we're saying, like, let's take a polynomial that's given to us, and can we break it up into its constituent factors? And so that's what we did just yesterday. And so we know that what you have to do is you have to look at the factors of like 4. So you have to look at, are there two numbers that multiply to 4 and add up to negative 5? And if you think about that for a moment, you might say, yeah, right. So negative 1 and negative 4 will multiply to 4 and add up to negative 5. So you'll get like v minus 1 times v minus 4 as the answer there. For this one, what two numbers multiply to 6 and add up to negative 5? So you can make the chart of like, what are the factors of 6, including negative numbers, and which ones add up to negative 5. You can also look at other exercises on page 389. And that's really it. That's the whole semester in 40 minutes. So what I'll do is I'll put all of this text up on the Google Classroom, and you can see all these examples, these problems. And so I'll just pick from these problems, and that'll be the assessment. And you'll have an hour to do it. And you will need to come to the class. It will be synchronous. So I'll put a link to it in the chat. So once you come to class, then I'll put a link to the assessment, and you'll have an hour to do it. And of course, I'll be here to answer any questions that you've got. And that'll conclude the whole semester. So we've got this class runs from 10:05 to 11. So we've got up to 13 minutes left if you want to take it. I'll do any of these problems in detail, or I'll do any other problem that you'd like to see, or answer any other of your questions. So I'll turn the floor over to you. Do you have any questions or anything you'd like me to do? So that being the case, I'll just encourage you to work on this overnight. Email me with any questions, or like if you want to get in contact, I'll be happy to speak with you. I'll see you tomorrow for the assessment. It's been a wonderful semester. I hope we get to spend more time in person next semester. I value all of you. I thank all of you. And let's just let you out about 12 minutes early and take a little break. So thank you for your time and attention. I'll see you tomorrow at 10:05.
Thank you, Ken.
Thank you.
Thank you.